Good evening everyone. I am Dr. I. Veeranjaneyulu, Coordinator of Aditya Learning Academy, ALA, Aditya University, and it is my pleasure to welcome you all to the online certification course on Design for 3D Printing. This event is organized by Aditya Learning Academy in association with the Department of Mechanical Engineering at Aditya University, Surampalem. Let me start by giving a brief introduction about Aditya University. Aditya University is a premier institution committed to excellence in education, research and innovation. It is located in Andhra Pradesh, India. The university offers a diverse range of undergraduate, postgraduate and doctoral programs across various disciplines, including engineering, management, sciences and medicine, arts and humanities. With a strong emphasis on academic rigor and industry-oriented learning, Aditya University collaborated with the top global institutions to provide international exposure to students through study abroad programs and research partnerships and faculty exchange initiatives. The university also fosters entrepreneurship and innovation, equipping students with the skills needed for the evolving global level job market. Aditya University is home of state-of-art infrastructure, cutting-edge laboratories and vibrant campus life that nurtures intellectual and personal growth. The institution is dedicated to shaping future leaders by providing a holistic education and intellectual theoretical knowledge with practical experience. Now I would like to introduce about our Aditya Learning Academy. As a center for teaching and learning at Aditya University, ALA is dedicated to achieving education through various specialized certification courses. So far, we have conducted successfully 5 online certification courses and 2 online lecture series. Online certification courses are Machine Learning and Gen AI, conducted from August 5th to 16th in 2024. Data Visualization with Power BI and Tableau, conducted from September 23rd to October 4th in 2024. AI Tools, conducted from December 23rd to December 28th in 2024. And Digital Hardware Engineering with FBGA, conducted from February 19th to 25th in 2025. Harnessing Big Data, Business Analytics with Oracle Database, March 10th to 15th in 2025. In addition to these 2 online lecture series have successfully conducted. One is Emerging Trends in Research in Electrical Engineering, held from November 6th to 16th in 2024. The second one is Research Scope in Emerging Areas of Civil Engineering, held from 21st January to 31st January in 2025. All of these programs received a great participation, and it is clear there is a strong interest in learning these valuable skills. Today we are starting another exciting program focused on design for 3D printing. A total of 168 participants have been registered for this program, which will run for the next 6 days. During this time, you will have the great opportunity to engage with our expert resource persons to explore the topics such as relation between design and manufacturing, modern trending in manufacturing, role of 3D printing in manufacturing, rapid prototyping and 3D modeling, Tinkercad, exploring 3D modeling software, handling 3D printing practices, 3D printing using FDM, quality control and optimization strategies, industrial applications, case studies on the real world implementations. This program is designed to help you understand these areas better and skills to advance your professional and personal growth. Total, this program have 3 resource persons. We are start with today's resource person is Dr. S. DVV Bhimeshwar Reddy. Dr. Bhimeshwar Reddy is a distinguished academician and administrator, currently serving as the head of the department and assistant professor in the Department of Mechanical Engineering at Aditya University. He is an academic leader responsible for managing and developing their department, ensuring academic excellence and smooth functioning of staff and resources achieving the department goals. Dr. Bhimeshwar Reddy expertise in alternative fuels. He actively engaged in research, mentoring and academic initiatives aimed at enhancing the quality of higher education. His vision is to create a dynamic learning environment that bridges the gap between academia and global industry standards. The other two resource persons are Mr. V. Satyasurya Prakash and Mr. P. Jayakishan. So these two resource persons were expertise in autonomous robots and also doing PhD in this field. These resource persons are mainly focusing on AI into robotics to enhancing the design, decision making and navigation. So finally, I would like to introduce today's resource person, Dr. Bhimeshwar Reddy, to begin the session. Thank you all and I wish you a productive and great learning experience. Thank you once again.
Hi, good evening one and all. Myself Dr. Bhimesh Reddy. I am the head of the Department of Mechanical Engineering and I was an assistant professor in Department of Mechanical Engineering, Aditya University, Surampalem. Before going to explain about the today's concept, which it is design for 3D printing, you are having a design is a plan or a concept for creating something. Okay, whether it is a physical object, a system, or we can say even an experience. Let us give an example for design. Like we are having a product design, a software design, architectural design, and also a business process design. Here, while going to this design, if I want to explain about a product design, let us know about a bottle, Kinley bottle. You know about a Kinley bottle. Here we are having a concept I can show it to you. See the Kinley concept, see the bottle here, and in this Kinley bottle, how it will be designed? This is nothing but a plan which it is having to create a bottle, a volume like 1 liter of bottle which it was created, right? So, and if I need a half liter bottle, the same design which I need to create another one, so that I can take another one. See here, see the design here. This is the volume which it consists of a half liter bottle, and which you are having the another one which it consists of 1 liter bottle. Okay, this is nothing but an idea which it is having a product. And now I can show it to you another one which it is having an aluminum. Like see here, this is a steel bottle, or else we can say aluminum. Like aluminum bottles are there nowadays. We are using like different materials we are using for the bottles. Like you can see this bottle. This is a stainless steel bottle, and which I have shown previously that it was like a plastic bottle. Okay, is it clear? This is nothing but a product which we can show it to you. Like that, you are having a software design. While coming to the software design, you have to say that whether it will be created by using a CATIA or else something like SolidWorks. So many designs are there. By using that, you can create a design. Okay, and coming to this architectural design, which I can say that which it is useful for the civil engineer. They can create their buildings, plans, everything by using this architectural design. Okay, and also like we can say the business process design, that it is something which it is nothing but have to take some layouts. Okay, while taking the layouts, and they are planning whatever the business process will be there, that it will be occurred in this business process design. Okay, while coming to this design in engineering, which it is a systematic iterative, the process of problem solving and solution creating, and also involving which it is nothing but a creativity, and we can say that the technical knowledge and the application of scientific principles. Now the today's concept, which I can say that the design for 3D printing is very useful to the human being. Now we can start our session with the first slide, so that we can go here the design for manufacturing. Why we have to go for a design for manufacturing? which it is a process of designing products in a way that makes them easier and also which it is more cost effective, and coming to here which it is easy to manufacture, and also we can say it aims to minimize the production cost and also improve the quality and the reduce time to market, which it is having a concept development. You can see the cycle which it is having a the concept development. Coming to the first one, see here, now whatever the design it will be, in the design of our manufacturing, coming to here I need to go for a concept development. The concept is very clear. First of all, whatever the product it will be, you have to develop, means you need to ready to give the concept, and after that you have to go for the design optimization. Optimization is very important here. While completing the design, if it is not optimized, then it impacts to the cost definitely. For that, what you have to do, you have to give the design optimization, and next that it replicates the prototype testing, whether that it will sustain or not, the product will sustain or not, you have to go for the prototype testing, and after that you have to go for the feedback integration. Why? Because whether the product will sustain or not, that is what you have to say. While coming to this plastic bottle, that is a Kinley bottle, whether it will sustain or not, you have to check it. Then we can go for the another model. If it is not sustained, that means whatever the feedback we are getting from that, if it is not sustained, then definitely you have to modify it. That is what it is required for the feedback integration. And after completing everything, the final model is ready. This is nothing but a final design. Now see the concept once again. Here you are having the concept development, and after completing that you can go for the design optimization and prototype testing and the model which it was prepared here, and after that you can get the feedback integration. The feedback is completed. If the model is ready, everything is ready, then you can go for the feedback integration. If it is the prototype is ready, then you can go to the final design. The final design is ready, and if any modification is occurred, then definitely have to go for the concept development. Again, if any modification is required, you can do the modifications in the concept development, and again the recycle the process. The process will be recycled here. This is the process which I have in design for manufacturing. Can you please check it here? That is nothing but we can say that the design is a let me say the design for manufacturing is a process of the design products, is a way that makes them easier and also more cost effective and also more effective to the manufacturer. Okay, let me explain the another slide. Here you are having the design for manufacturing principles. I need to explain about the design for manufacturers principles by using these concepts. You can say that having a simplicity, assemble and standardize materials, tolerance, environment, review, iterate and prototype and test, and also like finally you are having a process. Here the simplicity, coming to the simplicity, whenever you want to design a product, the thing is keep the design as simple as possible while meeting the functional requirements that is necessary for a simplicity. You have to design for a manufacturer the first principle which it is nothing but a simplicity. You have to go accordingly. Okay. Just a minute. Let me see here. Now the simplicity which it is having, right? Now coming to the assembly. After completing the design, definitely you have to go for the design like assemble. You have to assemble the product which it is necessary. Nowadays we are seeing some laptops. Say sir, Why? Because we have to design a part. After completing that, whatever the components are there, which it is aligned fastly, easily aligned, and also fast, and also which it is having connect. The laptop which you are having the design like this, and you can fold it very easily. That is what it is required. While assembling the parts, that means that it is having a hinged joints. By using that, what we are doing simply, while the screen, if we want to close the system, then definitely I have to close the laptop. That is required in that. Okay, that is what we have to go for the simplicity, and after that we have to assemble according to the simplicity manner. That is required. And coming to the standardize, it is required. Why? Because while utilizing the standardized components, the materials and also the processes where whichever it is possible, whichever it is required. This is nothing but a standardized. Whatever the component you have to do, that which it needs some standardized components. While the material is also the main factor in this standardized. And coming to the materials, choosing the materials for it is why? Because why I'm saying about the materials, if we are going for economical, that is required. See, choosing the materials that are available, which the first factor which it is the cost effective. Yes, and after that we can say that, and also which it is suitable for the manufacturing processes, whether it is suitable or not, you have to check it. Then only we can go for the materials. And coming to this tolerance, we can manage the tolerances and to design whichever the ensure components and whether the component is fit together collectively or not. That is what you have to check it in this. If it is not fitted, then again you have to modify all those things. The tolerance is the main factor which it is very important. Why? Because if I am saying it is a pen, it is a pen, it is having a cap, and if I want to introduce a cap into it, then what I have to say simply, whether it is fitted or not, that is what you have to check. That means you have to go for a tolerance, whether the design is ensure the components, whether it will fit togetherly correctly. Okay, that is what it is required in a tolerance. We can go for it. And also materials like, and whether the material can sustain or not, we can go on to the environment. We can design the product for the environment which it will be used. Nowadays you can see global warming and such type of effects will be there. For that, what we are doing, Modi is introduced like plastic, no plastic. They are saying simply no plastic, that is environmental related. Why? Because we have to follow such type of manner in the environment. Okay, and coming to this review and also iterate, we can say that which we can hold the design, the regular design reviews with the cross-functional teams, and also we can continue to iterate the achieve the desirable objectives or not. That is what we have to check it in this. Definitely we have to check it in this, and after completing that, whether the review and iterate, whether the review we have to check it whether it is available or not. What is a product review, that is also we have to check it, whether that it can sustain or not, and after that only we can go on to the review and iterate. And finally the process, we have to go for prototype and also test. In the prototype and test, first of all, after completing the product, what you have to do, we have to go for a prototype. In this, whatever the design is there, that is validate to function, and after that, whether the performance is good or not, you have to check it in the prototype. That is required. Okay, and ensure whatever the compliance with all the industrial standards, that is required. With all the industrial standards only we can go for the prototype. Something like here I have to mention that what are the standards you are having, like AISI, American Institute of something like standards will be there. You have to follow that. ASME standards are there, AISI standards are there. Accordingly you can follow it. follow accordingly. That's what I'm saying, that whatever the design for manufacturing principles are there, you have to follow accordingly, like simplicity, assembly and standardize, materials and tolerance, environment, review and iterate, and also like prototype and test, and finally you are having a process. After completing the process, if the process whatever you have done, if the process is done, everything is done, so you can go for the product. Okay. If not, again the process will be started like this. Okay, is it clear about the design for manufacturing principle? These are all nothing but the design for manufacturing principles. And then going to the next slide. Close. Just a minute. And now see the next one. Here you are having the design for manufacturing and also different manufacturing processes. Here I have to show the different manufacturing process by using injection molding. First of all, you have to go for injection molding. In this, we can avoiding the undercuts and uniform wall thickness, and also considering the draft angles. First of all, sir, what do you know about a injection molding? How can you introduce about injection molding? This is the process in injection molding, which you are having a bed like this and having a support and having a screw. If you can check here, the raw material, whatever the PVC material will be there, that it will be poured into it, and which it is goes to in a molten plastic, that it will be goes to the die. Here you are having a molten cavity will be available here. If you can check it here. Can you check it here? Like we can see that mold cavity is available, and also like we can say the molten part which it is having, and after that, after completing whatever the mold you are taking here, that it will be ready. When it will be ready, after pouring the material, some temperature will be enter into it, some temperature like 1200 or something else, some temperature will be there according to the standards, whatever the temperature it is there, and accordingly you can, whatever the molten part is there, it is available. Okay, the die will be prepared, and after completing that, whatever the part is occurred, that it will be occurred. Okay, I have shown a plastic bottle previously, that it was a die model. By using the injection molding only it is happened. Okay, do you understand about it? I think so, right? You are having the injection molding machine, which it is also called as injection molding machine, right? And coming to the CNC machining, here you can reducing the unnecessary complexity and also avoiding the deep pockets and ensuring that machinable features which you are having a like there are so many types of industrial machines. CNC machines are there. Computer numerical control machine. In this computer numerical control machine, you can see that the first one which we can talk about, the turning, milling machines are available. Whatever we can reduce the unnecessary parts. For suppose if I want to prepare a tie rod, that it is like in automobiles, the part which it is connected to the tires for steering, which it is like a tie rod, which it is available like this, and I want to reduce the material for a tie rod. For that, what I have to do? I have to go for computer numerical control machine. See the machine which it is available, which it can hold the part, and after that, what it will be done? Like it can turn the part, right? It can remove the material in the top itself. That means whatever the diameter will be there, that it will be reduced. Okay, is it clear? By using the CNC machining, and also like sheet metal fabrication. In the sheet metal fabrication, there are so many types of parts are available, like punching. If you can see here, like whatever the minimizing bends, using standard hole sizes, and also you can see the simplifying cutting paths. Nowadays we know so many types of monitors are available, and accordingly cabinets are available. In the cabinet, can you check in the cabinet? In the cabinet itself, the model which you are having like a rectangular size of like part will be there. For that, we can do this type of holes that is required. Why? Because for a ventilation. For a ventilation it is required. For that it is completely prepared by the sheet metal. For that what we are doing here, punches are required. So whatever the hole size is available, accordingly you can follow it. And that is about the sheet metal fabrication. We can do so many methods. Punching is required. Something like punching is required. So that we can do. And so many bends are required. The bend is also done by using the sheet metal fabrication. And coming to the last one, the today's topic, which it is nothing but a 3D printing. Why we have to go for a 3D printing? Simply we can optimize the printing orientation. First of all, the print orientation. Whatever the part it is required, which it is having a complexity shape, we can prepare by using the 3D model. We can reduce the overhangs also, and also by considering the layer addition. That is what we can deeply go on in the next slide also. I will explain. Let me explain about it. And here, which it is nothing but a 3D printing machine. Here you are having a 3D printing machine. Is it clear? Here you are having a nozzle. By using this, the layers will be prepared. Here, layer by layer, it will be formed. Okay. Let me explain about the next one. Let me explain about the next one. Like we can having a strategies for aligning the design and manufacturing. Here you are having we can apply the DFM principles. What type of principle it was? The design products that are easy to manufacture, and also we can assemble. Whatever the products we are taking here, according to the standardize, and we can say that we can accordingly we can design it, and after that we can manufacture the parts that is required. Previously we discussed about a slide that is nothing but the DFM principles. Already we discussed some of the part. Accordingly we can follow it, and we can manufacture, and also we can assemble the parts. And coming to this early collaboration, which it is required, that is we can see the involved manufacturing engineers in the design phase to identify the potential production issues. You can see the laptop itself, one hand is there. For the hand you are having a gloves. The gloves is available. The complexity of the part which we can prepare, but that it is by using, we can say that use CAD and simulation tools. By using that we can prepare, and after that some standardization will be there, and after that we can go for the rapid prototyping like 3D printing. This is the 3D printing process. Now I can say that easy collaboration, early collaboration is required, and after that use CAD and simulation tools. What type of CAD and simulation tools? We can predict the manufacturing feasibility, and also we can say that optimize the design before the production that is required. Why? Because if I want to design this type of, I can say that, just a minute. If I can go for this type of model, whatever the model I am saying, a type of CAD model, this is a CAD model, I can go for it. But the thing is, the complexity of design, if I want to complete the model, so that some scanner is available for the 3D printer, if I want to scan this type of thing, then the production will be very easy. For a batch of mass production, that it is before we have to go for the sample is required. For that we can go for a 3D printing or else a CNC. For that this type of process will be available. Use CAD and also simulation tools that is required, and like a standardization, we can go for a standardization. See the laptop here, this is the part actually I want to design it, and after completing that what I have to do, go for a simulation tool, whether it will sustain or not. First of all, check it on a design, and after completing that, what you have to do? Like we can go for a 3D printing. We can print this model. Yes, we can print this model, and after completing that, we can whatever the hand it will be using that we can enjoy it, right? This type of models we can enjoy it. That is nothing but a standardization, we can say. Use which it is commonly available materials and also components to simplify the production that is required. And finally, the rapid prototyping. Already I shown about you, like validate designs using the 3D printing or else like a CNC machining before a mass production. Before going to the mass production, which it is required, whether it will be goes to the 3D printing or else the CNC machining. It is completely based upon the mass production. Okay, right. I can go for the another one. Oh. Can you please take it the next one, next slide? So here I have to discuss about the manufacturing. What do you mean by manufacturing? Here the manufacturing is a process that converting the raw materials into the finished products and using various tools, machines, and by using the techniques. It plays a vital role in industries such as automotive industries, shipping, electronics, aerospace, and also like consumer goods. Sir, what do you mean by a manufacturing? First of all, you have to say that manufacturing is a process of converting the raw materials into the finished products using various tools. For suppose, if I can say that, now you are seeing the board, right? What type of material it will be? Maybe I think so, like we can say it is an interactive panel, right? Before that, what I have to prepare? You have to plan accordingly. I have to say that first of all, I can design it. What is the type of material? Whether it will be a plastic, I think so, plastic, and the panel which it is required, what type of size. I have to manufacture the product that it is required. Before that, whatever the converting raw materials into finished products that is required, for that what I have to do? Doing various tools. For some cutting is required. See, if the cutting is required, I can go for a cutting machine. Some surface roughness is available. Yes, I can go for surface roughness. I have to do the roughness. See, some lapping is required. I have to go for a whatever the thing it will be. According to the machining, whatever the required product is required, that means we have to manufacture. The raw materials is converted into the finished products using various tools. That is what it is done. Okay, and it plays a vital role in industries such as automotives, electronics. We know this is the electronic product. I already explained about it. In automotives also we can say that. Like if I want to prepare a chassis, nowadays you see so many types of cars are available. If I want to go for a Hyundai, the cost is different. If I can go for a car, Benz car, that is different. And if I can go for a Audi product, Audi car, that is also completely different. Why the difference is there? We are doing the manufacturing, but the thing is accordingly the safety and all the measures they have taken. Accordingly, we have to follow. That is also one type of important factor in this manufacturing. Like we can say that here the types of manufacturing. There are so many types of manufacturing are available. Here manufacturing process can be broadly divided into the following types we are having. Like we can say additive manufacturing, subtractive manufacturing, forming and shaping manufacturing, and also casting and modeling. And also we can say the lastly joining and assembly processes. Joining and assembly process. And coming to the first one, we can say that in additive manufacturing, what we are doing in the additive manufacturing? In the name itself, it is available, additive. What do you mean by additive? We are adding some to it. We are adding some material to it, which it is nothing but an additive. See, what type of additive manufacturing we are taking here? That simply I can say that define It involves the building up material layer by layer to create a product. In this you are having like 3D printing. Again our concept is coming design for 3D printing, and that like we can say 3D printing. Here we can say that is fusion deposition modeling. Fusion deposition modeling, stereolography, and also like SLS, selective laser sintering. Nowadays the manufacturing, like in additive manufacturing, so many advancements are going on in the mechanical engineering. We can take a product like I can say powder we can go for a powder also by using CSLS. We can say that fusion deposition modeling. And coming to the next one, which it is having a subtractive manufacturing. In the subtractive manufacturing, we can say that in the name itself it is subtractive. That means we are removing the material. It involves removing the material from a solid block to shape the product that is required. Simply I can say that we can go for a CNC machining, drilling, milling, or else we can go for a turning. In this, the first one is CNC machining. See, in the CNC machining, what we are doing, I explain about the CNC machining, whatever the product it will be. Some solid blocks are there, available with it. And in that solid blocks, we have to remove the material. Whatever the shape, I mean, whatever the design it is required for us, accordingly we can follow it. For suppose, if I can say that, see here, I can say about a subtractive manufacturing. In this subtractive manufacturing, I want to design a product. See the part here. See the part here. And in this part, what we have to do? See the material which we are having. For suppose, let me say, it is having a diameter of 100 mm. And whatever the solid block you are having, now it is a solid block, right? It is a solid block. In this solid block, I have to remove the material. That means I have to reduce the diameter. Reduce the diameter which you are having here. I can say that here up to here, something like I want to remove some 20 mm. 20 mm I have to remove. Here also some 20 mm it is removed. I can go for a CNC machining, like turning. I can say that I can remove the material. Okay, and here also something else like 40 mm I have to remove. What is the remaining? Here 40 and here 40 means I can say that the remaining which you are having 20. Okay, 20 mm is required, and here 20 plus 20 40. What about the remaining? The remaining I am having like 40 means this 60 mm. The remaining is 100 mm. Here you are having 100. This type of workpiece is required. Whenever it is required, I can go for a CNC machining. Definitely I can subtractive. This type of subtractive manufacturing, I can go for a subtractive in the subtractive manufacturing, simply I can go for a CNC turning or milling. I can say that. Okay, CNC turning we can say, not milling. Again, if I can go for a milling, like type of gear type of products will be there, that it is available. Accordingly we can follow it, right? And forming and shaping manufacturing, it is a process where the material is reshaped, and also without adding or removing the material. See, like the example which I have given here, the forging, rolling, extrusion, bending, and also stamping. For suppose, if I can say about a forging, nowadays we are seeing the drums. brake drums. Brake drums are required. For that, we are using like forging process. Forging process is very important, and also like extrusion, rolling, which it is having. See, in a rolling, I can say that um, in a power like a steel plant, if I can go for a steel plant, light and medium merchant mill will be there. They have manufactured like a product which we are having like steel rods completely, which it is go for an extrusion process. Okay, light and medium merchant mill. They are preparing the sheets. They are preparing the sheets. But like it is a batch production, mass production, we can say. Like bending is required. That is also which it is includes in the forming and shaping manufacturing. Bending and also stamping is required. See, if I want to say that in an automobile, two-wheeler or a four-wheeler, the chassis is required. In the chassis, how can you say that your car or else your bike? Definitely some stamping is required for that. What type of stamping, sir? Yes, for a chassis, there is a number. There is a number like CE2, something else, the number is required. Sir, how can you prepare a stamping again? Like you are having a punching metal will be there. Punching metal will be there. In this, if it is upon here, something like letters or else numbers are required. Accordingly, what we have to do? We have to give a punch. Accordingly, which it is follows. Like stamping also, which it is follows. Right? It's clear about forming and shaping made manufacturing. And coming to the last, which it is having casting and molding. In a casting type of metal, casting and molding, we can say that the liquid material which it is poured into the mold and solidifies to form a specific shape which it is having. Like we can say the sand casting. The best example, sand casting, die casting, injection molding, and also blow molding. See, like injection molding already I explained about you, and also the blow molding. The both are simply like a same process which you are having. A plastic bottle which it is prepared by using the injection molding. That is the best example for a molding process. And also so many casting components are also available. Like I told you about a first one is the casted component which you are having drums. Drums which you are having like casting process by using it. And finally, the last process which you are having joining and also assembly process. In this, you are having it involves the combination of two or more materials or components which we have to create a final product. That means which I can say that in the joining process, like we can say riveting by using the rivet. See, like welding, the two components are available which I have to weld. That is required. That is like gas welding or TIG or something else. Welding is nothing but we are adding a two components in it, right? For that we can use a weld. Okay, and if you can see that in all the combination of two or more materials, like I can say that soldering, we can say about a soldering also. Adhesive bonding. Adhesive bonding is nothing but we know that is a gum type of metal is available. Accordingly, whatever the adhesive we are taking, accordingly we can follow it. That bonding is required. That bonding is required. Okay, and also like we can say mechanical fastening. Like we can use screws. The fastening material means screws or nut and bolt. We can say about a nut and bolt. By using the two parts, whatever the mating is required for that, the mechanical fasteners also, which it is helpful for it. Okay, like we can use screws also, fasteners, or else nut and bolt. By using that also we can using this assembly process, joining and assembly process. Can we take a 5 minutes break? Yes. Now you are having a quiz. Please go on to the link. It was ready. Thank you. Please go on to the quiz. Now it is available with you. And after that we will continue the session again. The few more concepts are there. We'll continue definitely. Okay. here in this you are having like the modern trends in manufacturing. What are the modern trends in manufacturing? Generally, you can see that here you are having a smart manufacturing in Industry 4.0. So you are saying about a smart manufacturing. What is smart manufacturing and Industry 4.0? Simply, you can say that smart manufacturing, which includes like sensors, IoT, this type of things are available in the smart manufacturing. And how about the Industry 4.0? Here in the Industry 4.0, which it will integrates the digital technologies to create intelligent, automated, and also data-driven manufacturing. Okay, and here the Internet of Things like sensors and smart devices, the collect real-time data to optimize the processes. And coming to this AI and ML, nowadays you know that which it is having a trending subject, artificial intelligence and machine learning, AI and ML, which it is also driven. AI driven predictive maintenance reduces the downtime and also the improve the quality. And coming to this big data analytics, you are having like the large scale of data analysis will be enhances the decision making and efficiency which it is required. And coming to the cyber physical system, CPS, we can say, which it is having an integration of digital and also the physical systems for the smart production which it is required. Simply we can say that here it's a combination of the smart manufacturing and Industry 4.0. If you can observe this diagram, you can see the automobile. Here you are having an automobile which it is integrated the manufacturing part, and also we can say that whatever the sensors, diodes, everything is helpful to Industry 4.0 also. Okay, that is the first concept of the modern trends in manufacturing, which it is the smart manufacturing Industry 4.0. Now coming to the second concept, which you are having, I can say that additive manufacturing. In this additive manufacturing, the today's concept, which it is nothing but a 3D printing. Here you are having the additive manufacturing is transforming the production by to allowing the customized and the complex design with the minimal waste. Whatever the thing it will be, which it is also known as the additive manufacturing. In the previous I explained about it, right? Some additives like we can see that addition of material is required in this 3D printing. Slices, the slicing software will be there. Like what about the metal? It will be layer by layer which it is deposited. Okay, that is what we can say about a 3D printing and the additive manufacturing, 3D printing. And nowadays, not only the plastic, we can say that the advancement in mechanical engineering, which it is the metal 3D printing. Hopefully, I know that use in aerospace, automotives, and also healthcare, which it is nothing but lightweight and also the durable parts are available. And we can say that if you can see here, this is nothing but whatever the model which I am showing here, that is metal 3D printing. It was prepared by the metal. Then the last one, which it is nothing but the bioprinting, the printing human tissues and organs for medical applications. Which it is simply I can say that nowadays the bioprinting is also the main factor. Why? Because something like having a loss of leg or else like a hand, so that we can create the bioprinting that it is required, so that the main application for the bioprinting is the printing human tissues and also organs, which it is applicable in a medical applications. That is possible. Nowadays it is a modern trend. We are using it. Okay, and coming to this multi-material printing, it's a combining different metals in a single print for enhancing the performance. Having a simply I can say that. What about the dual combination? The dual combination is also very important here. Okay, while coming to this, the multi-material printing, we are combining the different materials and we can go for a printing. Okay, The deposition what we are taking, that it will be the dual material. And now you can see the third one, which it is having automation and robotics. Nowadays everything is automation. Automation and robotics enhance the manufacturing efficiency by reducing the human labor and errors. Suppose the job what we are doing here in the manufacturing, if it is an automation, definitely the errors will be reduced. If it is a human, like some errors will be there, definitely sure. But accordingly, we can see that when the automation is going on, the percentile will be reduced. We can say that the cobots, the collaborative robots, we can also call as collaborative robots. In this, work alongside human for improved safety and productivity. That is what Industry 4.0, which is going on. The human are working along with robots. That is nothing but an Industry 4.0, which is going on right now. And coming to this, we are having see the productivity how it is going on. See the cobots, the automated machines, that it is going to prepare something else, whatever the product it will be. If I want to go for a well, yes, definitely it will do the well. And after that, some assembly is required. The cobots will do done everything accordingly, right? And coming to that autonomous mobile robots, we can also call it as AMRs, ARMS. In this, whatever the warehouses and also the assembly lines for a material handling. Now you can see the assembly line here. We can call it like autonomous mobile robots. Nowadays, the production has happened. Whatever the mass production is happened, uh, like in a automobile industry. For suppose if I want to prepare a car door, the car door is prepared. How it will be prepared? That process includes the chassis is required for that, the design is required, and after completing that, whatever the chassis material, doors material will be there, it will follows. The cobot will prepare everything. It is done by the autonomous mobile robots. Now the foreign countries, not only the foreign countries, now the Indian are also doing this type of manufacturing. Now the industries in India, those are also going for the autonomous mobile robots. The process is going on. We are also well developed, right? And AI powered robotics. AI, which is nothing but an artificial intelligence. We are including the artificial intelligence in a powered robotics. In this, we can say that the intelligent robot that adapt and also learn from their environment, like a human mind. See now, I'm sitting in this room, having like the temperature, whatever else it will be. Like if I need, if the temperature is reduced, then that sensor which it is adjusted. That is the thing of AI, artificial intelligence, right? For suppose if I can say that the temperature which it is continues like that, what happen? The room will chill, then definitely some cold will occur for me, right? But the thing is, if I want to use the AI, then definitely I can say that which it will be controlled by using it. That is nothing but we can say that AI powered robotics. And coming to the next one, we can say that here the sustainable and also green manufacturing. It is also one type of modern trend in manufacturing. We can say with increasing the environmental concerns, manufacturers are adopting eco-friendly practices. We have to go. We know the global is affected by different issues, global warming or something else, something else. Now we are going for eco-friendly practices. See the layer here, I think you understand about it. Again, once again, I will have to explain about it. The sustainable manufacturing process, it is we have to go for the manufacturing cost. that it replicates again into the sustainable manufacturing and energy consumption. It is also one type of sustainable consumption manufacturing. Again, waste management, operational safety, personal health and environmental impact, and again manufacturing cost. All or relates again, all or relates. Why? Because if the manufacturing cost is low, if you are going high energy, that it is not at all useful. The thing is, we have to maintain low economical cost and also we go for low energy consumption and also low waste of material and also low operational safety. Whether it is low or high, definitely we have to go for operational safety will be high. And here the personal health is also required. See, like factories or industries, so many people are working. Different issues are there, health issues. Due to that industries, the personal health is also very important. We have to concentrate on it. Okay, and again the environmental impact, releasing of gases, waste, everything, whatever it will be. That again it will comes to the cycle. Again it will comes to the sustainable manufacturing process. That is the thing we have to go like that. And also the use of renewable energy. Here the solar, wind, and hydro turbine, hydro energy to power the manufacturing plants. And the final one, which it is having the recycling and circular economy. We are reusing the materials and the reducing waste that is required. And the energy efficient equipment, we can say that the machine designed to consume the less power, that is also required in this. And here the modern trends, one more modern trend in the manufacturing, which is nothing but digital twins and simulation. If you can observe the diagram here, see the picture, and is you are having a model, the same type of model which it is available. See the CAD, which by using which we can call it like a digital twin, and the simulation is also happened in that. See, which it was nothing but it is replicas of the physical manufacturing systems which are used in real-time monitoring and also simulation that is available, which we have to do. After completing everything, what we have to do, the digital twin and simulation will be happening accordingly. Right, real-time data integration. Whatever the sensors will be there, we can collect it with the data from machines. The simulation and optimization we can do by using whatever the predicting failures and testing new designs and optimization workflows. Accordingly, we can follow it. This is an excellent modern trends in manufacturing, one of the digital twins and simulation. And the final one, which it is having the advanced materials in manufacturing. Here also we can see that whatever the new materials are being adapted, that to be developed to enhance the product durability, efficiency and sustainability. If you can see here in the potential, I am taking an example which it is having a carbon nanomaterials, the potential of carbon nanomaterials, that it is having the damage tolerance, having a high fatigue toughness and wear resistance that is required for a material. And also here optical transparency, which it can use the strong light absorption as a black body with applications to light emitting diodes, LEDs, we can call it like LEDs, and photo detectors we can call. Now coming to the last one, electrical conductivity, which it is also like anti-static plastics for dissipation of static charges, and also we can see that lightening the striking pollution, barrier coatings, power storage, lithium ion batteries, we can say the lithium ion batteries, and also like super capacitors. Here the structural reinforcement, these are all nothing but an applications we can say, right? This is the potential of carbon nanomaterials which are useful, thermal conductivity and also strain sensing. See here the smart materials, nanomaterials and also smart materials, and also like biodegradable polymers. Now, the role of 3D printing in manufacturing. We can say that, what is the role of 3D printing in manufacturing? Here, the 3D printing is a process where materials are added layer by layer to create a three-dimensional object from a digital model. We can say, if you can observe the prototyping here, I need this type of diagram here. This is nothing but I'm thinking that whether it is a nut or bolt, whatever else it will be. Now you are showing which type of replica is available. That is what I'm thinking. And after that, I want to design by using this system. And after that, that replica, whatever the design I am having, that it will be done by 3D printing. That it will be done by 3D printing. Okay. That means I'm thinking that this type of bolt is required, nut or bolt. And that replica which it is available, we have to create a design in this system. And it is prototype whatever it is available by using the 3D printing, I can done. See here, that is what using the traditional subtractive manufacturing which removes the material, but here the 3D printing which build up the parts and also reducing waste and enabling complex geometries. These are the applications of 3D printing in manufacturing. See the rapid prototyping. Engineers and designers can quickly creating the prototypes for testing and validation. In the next classes, I think our resource persons, few more resource persons can explain about it, how to take the 3D printing, what type of material they are suggested, and how to design Tinkercad. Everything will be available. Accordingly, we can follow it, right? These are the applications, and we can once again the rapid prototyping, customization, personalization, and finally the low volume production and one demand manufacturing. That it is nothing but we can say the small batch production for specialized industries like aerospace and also luxury goods, and complex geometries and lightweight structures which it is required. Tooling jigs and fixtures. If you can see the diagram here, these are tooling jigs and fixtures, the custom jigs and fixtures for assembly lines, which are hopefully it is helpful to us, useful to us. This is about today's class. I think hopefully you have enjoyed the session. I think the maximum session I have covered in the first one. Thank you so much.